Hello. Today I'm going to show you a method to work with equations that have double signs. Because sometimes we're given equations that may be easier to solve if we rewrite them. For example, the following expressions are equivalent. 8 plus negative 3 is the same as 8 minus positive 3. And 9 minus negative 1 is the same as 9 plus 1. So we're going to use this knowledge to rewrite the following equations before we solve them. So if we look at this equation, just by looking at it, it can be confusing what inverse we want to use. We see a plus and we see a negative, and so trying to decipher what inverse sign or operation we want to use. So this is a method that might help you to rewrite it, and then it's going to become more clear what you need to do. If I look at my first equation, I have w plus negative 6. And if I use this as an example, this happens to be 8 plus negative 3, we could write that as 8 minus 3. So we're going to take this w plus negative 6 and we're going to rewrite it as w minus 6, because adding a negative 6 is the same thing as subtracting a positive 6. And when we write that, now we're like, oh, we just have one sign to look at. So as I look at this, I see minus 6, or you can look at it like it's negative 6, and we want this number to go away. We want to isolate the variable. So what we're going to do is we're going to build our wall, and as we learned, we're going to do the opposite, which is adding 6 or a positive 6, and I must do it on both sides. These two sides have to be identical. That's called balancing your equation. And now we're going to say what's left over on each side. These undo each other, zero out, which leaves our variable, w, which is what we wanted, and we add 27, and we add 6, we get 33. So using letter A as an example, would you please try letter B? Please rewrite the equation first, and then solve it. You can pause the video and start it when you're ready to look at the answer. So hopefully you rewrote the equation as y minus 14. Y plus negative 14 and y minus 14 mean the same thing. And on the other side, we still have our 25. That goes untouched. So now we're going to build our wall, and we're going to do the opposite of minus 14 or negative 14, whichever way you choose to look at it. I'm going to add 14, or consider that a positive 14 if that helps you. And so now we've done our inverse operation. Recall that it shows up on both sides. What that allows us to do is these become 0, leaving our y, and on the other side we have y equals 39. That's our solution. Again, we could always go back to the original equation and check this. We think that y is 39. So I'm replacing this y with 39. The original equation said that I'm going to add negative 14 to 39, and I should get back 25. So if you want to check that on your calculator, you can, but I can assure you that's true. So now let's look at ones that are a little bit more complex. Let's go to letter C. Before we begin, I just want to draw your attention to this numeric expression. When we worked with these earlier, this was never comfortable to see those double signs, minus and negative. In fact, what we chose to do is do a keep, change, change. So we did a keep, change, change, and we're able to write this. If I change that and change that, becomes this, and that's much easier to look at. So now we're going to apply that to our equation. We're going to actually do a keep, change, change on this side of the equation. And the x is going to stay the same. We keep it. We're going to change our minus to a plus, and we're going to change the number behind it to its opposite, which is positive 18. And this is much easier for our brains to comprehend and for us to look at. So now come the solving steps. This one we're going to solve by building our wall. We're going to subtract 18 on both sides. And then on the right side, these cancel each other out, leaving a 0 and x. So we've isolated the variable. And our answer here, we'd have to borrow, and we would get 34. So if we went back, let me clean it up a little bit. 34, thank you. So now, if I wanted to do a check, I could go back to the original equation. I could put 34 where the x is. I'm replacing x with 34. The original equation said minus a negative 18 equals 52. Now, you can put this exactly how you see it in the calculator, and you should get back 52 if you entered 34 minus negative 18. We could also help ourselves out by doing a keep, change, and change. And so this is really 34 plus 18, and that is indeed 52. Both will work out on your calculator. So what I'd like you to do is I'd like you to pause the video, rewrite letter D, and then check back when you're ready for the answer. All right, if we rewrite this using keep, change, change, this is what we now have on this side. Much easier to look at, much easier to solve. So we're going to draw our wall, subtract 9 on both sides. On this side, our m is isolated, and on the other side, we have to borrow. And the answer is 26. So this is our solution. It's called a solution. So I'm going to replace the m, but I think I'm going to choose to do the rewritten version this time, since these mean the same thing. I'm going to put 26 where the m is. I'm going to add 9, and that will equal 35. So that's my check. So please turn to the next page. So now you may be wondering, to rewrite or not to rewrite? That's the question. Decide whether you need to rewrite the equation below before you solve it. Justify your decision and then solve using the inverse operation. Please show your work. So our first equation is w minus 18 equals 50. Do we need to rewrite it? Yes or no? Well, the answer is no. We don't need to rewrite it. Why? Well, we just see one sign there, and we could easily solve this by using the inverse of subtracting 18 by adding 18. There wasn't a reason to rewrite it. Why? Because this equation does not have double signs. So we don't rewrite equations unless it helps us. So there's no double signs. So let's look at the next one. This says n minus negative 4 equals 16. Rewrite, yes or no? Well, the answer is yes. We do want to rewrite this. Why? If you said it's because there's double signs, you're correct. This equation has double signs. So we're going to use a keep, change, change. N plus 4 equals 16, and now this equation is much easier to solve. So would you pause this video and solve 11 and 12? Finish solving for me, please. All right. So what I'd like you to try is I'd like you to try 13 and 14 on your own, and please answer the questions off to the side. Check back in a few minutes for the answer. Okay, so let's discuss this briefly. We did not have to change this. It was just plus 12. There are no double signs. So we use the opposite of adding 12. We subtracted 12 on both sides, and g equals negative 45. Here's the check, and it did indeed check. So on this equation, we did have double signs, and adding a negative is the same thing as subtracting its opposite positive. So we had, once we rewrote it, we had to add 15, and this may not sound like it's a sound answer. Sometimes when I'm not quite sure that answer makes logical sense, I go back and I definitely want to check this. I'm replacing y with 5. I'm going to add negative 15, that's the original equation, and it should give me negative 10. So if you put 5 plus negative 15 in your calculator, it will indeed be negative 10. Thank you for watching this, and I hope this was helpful. I just want to let you know, too, that this is not the only way to solve these kind of equations, but a method that I find helpful, and I hope you do, too. Take care.